Okay, so here's your conic sections. You have a circle, right? You have an ellipse. You have a hyperbola. And you have a parabola. So here's the general equations of them. So we'll start with the circle. It's x minus h squared plus y minus k squared equals r squared. And h and k is the center of the circle. So we've covered circles a little bit before. So that one's not completely new. Now the ellipse, it's kind of like the circle. It's a plus between it as well. So it's x minus h squared over a squared plus y minus k squared over b squared equals 1. So really a circle is the same thing. It's just that a and b are equal on a circle. So on an ellipse, a and b are kind of, well, we'll just put this. HK, that's the center. A is the horizontal distance. From the center to a vertex. So horizontal distance from center to vertex, from the center to the vertex. And B is the vertical distance. So I think of B like the B is with the Y. And they'll switch A and B depending on which one's the major axis. That's why I kind of am hesitant to write this. So that's when it's written like this. Normally they say A is always the bigger one. Okay. So if you have a ellipse that's more like this versus like this, A and B switch on the one that's up and down. So that's the difference. So this is like what we have up here with A being the major one. If it's like this, A and B switch. And so then, I don't know why they do that, but they'll write it that way. So we'll graph some of these in a little bit. Hyperbola is the same as the ellipse with one difference. It's minus between them. So it's exactly the same as this, but there's a minus. So it's x minus h squared over a squared minus y minus k squared over b squared equals 1. So that's the only difference between the ellipse and the hyperbola, is the hyperbola has a minus between the two of them. So HK is still the center, A is the distance, horizontal distance, and B is the vertical distance. And then the parabola, it's different on this one than what we have been talking about. Like the idea is the same, but we'll learn a different way to write it. So it's x minus h squared equals 4p y minus k. And that's for a parabola that opens upwards. A parabola that opens sideways is y minus k squared equals 4p x minus h. So this is a parabola that opens sideways. And h and k is still, that's the vertex on this. Same on the hyperbola, hk is still it's the center. So the hyperbola is the same as the ellipse. So on the ellipse, it doesn't matter which one goes first or not. On the hyperbola, it does because this is like a sideways one versus an up and down one. So on the hyperbola, if it opens sideways, like this one, the x goes first. And if it opens up and down, the y goes first. Kind of like on the parabola, it made a difference which one was squared. So up and down, the x one was the squared one. And side to side, the y is squared. Have you heard of a focus point before? So here's kind of the general idea. On an ellipse, there's 2 points inside of here that, like, if I had a string tied to them. So if I had like a string tied to it, if I held on to that and had a pencil, from the focus points, that string would create the ellipse. So like if I nailed down 2 nails in here, tied a string to them, came around, that would create the ellipse because there's 2 different points pulling on that pencil. So that's how the ellipse is kind of formed. But these 2 points are called the focus points. The other thing that they found about the focus points is, like, if you had light rays coming into here, so suppose we had a whole bunch of light rays coming and hitting this, and this was a reflective surface, these would all bounce and go through the focus point, kind of like your eyeball, right? So that's why some of us need glasses, is because our eyeball doesn't focus them to the right point. So that's what that does. So every one of these has a focus point. On the ellipses, they're inside. On the hyperbolas, they're in the parabola looking thing. And same with the parabola and the parabola, they're just inside the parabola. The distance, so on all of these, the distance to the focus is c. So there, I'm going to give you some formulas for each one of these. So the distance to the focus, from the center. So that's for the parabola or hyperbola and ellipse. For the parabola, we don't use C, we use P on this one, which should be nice if they were all the same. So P is the distance from the vertex to the focus. Now, here's the relationship on these. Kind of like our Pythagorean theorem type thing, but it's not Pythagorean theorem. So C squared equals A squared minus B squared. Don't worry, you're getting overloaded with a lot of information today. You should feel a little bit overwhelmed because there's a lot of information. We won't talk about asymptotes today, though. We'll hold off. So C squared equals A squared minus B squared. On an ellipse, what are A and B? And the same on a hyperbola. What does A and B stand for?
The distance from horizontal.
Yep. Good. So it's the distance from here to this point, and the distance, it's on the major axis. It actually goes through the focus. So A and B are these distances, and then C is just the distance to the focus. So that's C, A is this one, and B is this one. A is always the longest one. So A is always the longest distance. So A is always the longest.
So what is C again?
So C is the distance from the center to the focus. So the distance to the from the center to the focus is C. So on a hyperbola, it's different. So on a hyperbola, it is just Pythagorean's theorem. So A squared plus B squared equals C squared. Now on a hyperbola, it's kind of funky, but we'll end up drawing a little rectangle, and we get these dotted lines, and that's the A and the B. So A, B. Drawing the picture is a whole lot easier than the notes, but doing the calculations is kind of tricky. And then on the bottom one on the parabola, the P is just the distance from the vertex to, so that's the P, the distance from the vertex to the focus. There's better pictures in your book and such, but
What was the parabola?
the parabola, the distance from the vertex to the focus, that's the P. Like that's what that stands for. In this, so it says 4P. So 4 times P. P is that distance from the vertex to the focus. Okay. So now let's try drawing one of each of them. So x minus 3 squared over 9 minus y plus 2 squared over 16 equals 1.
So it's a hyperbola.
Good. So how did you know it was a hyperbola? Because that was going to be my first question. So good job. So it is a hyperbola because of the minus sign. Where's the center of this going to be? It's always backwards of these points. Yeah, so plus 3, negative 2. So on a hyperbola, you start, this is the same way as like a circle and an ellipse. You start like this. Now, underneath these, like the x minus 3 squared and y plus 2 squared, these numbers are a and b, but they're always squared. Okay, so on the hyperbola, this is always a and this is b. So this is a squared and b squared. So what's a? So a equals 3, b equals 4. So see how this is with the x? The 9 is with the x. That's how far left and right we go on the x. Okay, so whatever one is with the x, you go with on the x. So I go right 3 and left 3. And then the y direction goes 4. So 1, 2, 3, 4. 1, 2, 3, 4. Now if it were an ellipse, which this is not, it's a hyperbola. If it were an ellipse, you'd connect your dots and get that shape. So that's the only difference between an ellipse and a hyperbola, is you connect the dots on an ellipse. On a hyperbola, you draw a square. So imagine these are the middle of, or not a square, a rectangle. So I am going to draw dotted lines and make a rectangle. And then we're going to connect the corners to the corners. So we're going to draw the diagonals. So on your notes, if x is first and then negative and then y, which way does it open? Sideways or upwards? Did I tell you wrong? So it should be sideways. So it'll touch these dots on the edge of your rectangle. That's where the vertex is. And it kind of follows these dotted lines and curves and goes up. where's the focus? So for a hyperbola, this one is a squared plus b squared equals c squared. So a and b are 9 and 16. So that's 25 equals c squared. I made this one really nice. Uh-huh. So c is right there. Or did I count that wrong? Hold on, that's 4. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So that distance from the middle to that focus is 5. That distance is also 5. And they call this the major axis because so whatever the line is that has the focus on it is called the major axis. So like this way is my major axis. So whatever one's first on the hyperbola will have that major axis. Like it's the x direction. It's a vertical line direction. So there's another one to try.
Ashley Christensen.
So what's this one? Hyperbola, parabola, ellipse. So it's an ellipse because it has the plus, and they're both squared, right? Whereas on a parabola, only one of them would be squared. The center is so negative 3, 1. Always backwards of the sign. The x direction we go 5. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. The y direction we go. So 1, 2, 3. 1, 2, 3. And now since it's an ellipse, you connect the dots. They have what's called eccentricity, and it tells you how flat or how wide your ellipse is, like if it's more pointed or more rounded. But we didn't talk about that today. There's another formula to figure that out. So that's called, so I'll talk about it next time, eccentricity. So if you see that word, that's all that it means is your ellipse really like this, really like almost rectangular, or is it more footballish? So that's all it means. Now, where's the focus on this one? Let's do that, and then we can figure out what your assignment is. Your focus is somewhere inside of here. So on the ellipse, the focus will always be on the inside.
So,
Okay, and A is always the biggest. So 25 minus 9. So c squared equals, yeah, so c equals 4, good. So that's where the focus is. Yeah. So now you need some problems to practice drawing these on. Like I said, that was the whole chapter. Like that's all of chapter 7. Um, so on each of these, come on, voice, don't leave. Like this first part we've talked about somewhat. When you get to here, that's a little bit more tricky because you are given just information. If you'll draw the picture, it'll be helpful for that. So kind of draw the information they're giving you. And again, on Tuesday, we'll have to spend a lot of time on answering questions. On like page 662, you're drawing it first. But then the second part, you have to create the equation. So again, we'll have to go through some of that. And same on the bottom, like this part is drawing the picture and then this part's creating the equation. So on Tuesday, we'll do the second part where we are creating the equation from all that completing the square stuff.